2.1 Bonding Structure and Properties. The first learning objective is the properties of metals, ionic compounds, simple molecular covalent substances, and giant covalent substances. So the properties of metals are that they are malleable, ductile, conduct heat, conduct electricity, they are very strong, they have very high melting and boiling points. For ionic compounds, they are brittle, they have high melting and boiling points, and can conduct electricity when molten or dissolved. They cannot when they are solid. For simple molecular covalent substances, they have low boiling and melting points, and they have weak intermolecular forces between the molecules, and they cannot conduct electricity. Giant covalent substances have very high melting points, and depending on the specific structure, it may or may not conduct electricity. For our second learning objective, we explore the idea of the sea of electrons / lattice of positive ions, the structural model for the metals, and explaining their physical properties. So in the metals, there are giant structures of positive metal ions where the electrons in the outer shells are delocalized and therefore can move throughout the structure, essentially creating a sea of delocalized electrons. Metallic bonds are formed due to the electrostatic attraction between these positively charged metal ions and negative delocalized electrons. The properties we have for metals are that they are malleable and ductile. This is due to the fact that the metals can slide over each other, which allows them to be bent and shaped. The delocalized electrons in the metals can freely move about in the metals, and they can carry charge. This means that they can conduct electricity and heat. The metallic bonds that are formed between the positively charged metal ions and negative delocalized electrons require large amounts of energy to be broken. Therefore, they have very high melting and boiling points. In this next learning objective, we explore the idea of electronic structure and explain how ionic bonding takes place. Ionic compounds are formed when bonding occurs between metals and nonmetals, where electrostatic attraction occurs between positively charged ions to form a giant ionic lattice. Ionic bonding is where electrons from the outer shell of a metal are transferred to a nonmetal, where the metal lose electrons to become positively charged ions and the nonmetal gain electrons to become negatively charged ions. So we can use dot and cross diagrams to show how this happens. Below we have sodium and chlorine, where sodium is the metal, and we can see in its outer shell we have one electron. The sodium loses this electron to have a full outer shell and transfers it to the chlorine, which gains one electron, therefore having an outer shell, where there is a sodium plus and chlorine minus ions to form the ionic compound. For this learning objective, we explored the idea of the accepted structural model for giant ionic structures in explaining the physical properties of ionic compounds. The first physical property we can explore is the high melting and boiling points. This is due to electrostatic forces, which is a force of attraction between particles with opposite charges. This being positive metal ions and negatively charged non-metal ions in the crystal lattice. It takes a great deal of energy to separate the positive and negative ions, therefore they have high melting and boiling points. The second property we can explore is that they cannot conduct electricity because when they are solid, this is due to the fact that the ions are held firmly in place so energy cannot be transferred. However, the ions can conduct electricity when they are dissolved or molten. This is because the electric current can be taken in as the ions are free to move when they are dissolved or molten. In this learning objective, we explore the idea of how covalent bonds are formed and how it can be represented using dot and cross diagrams. Covalent bonds are a bond between atoms formed when atoms share electrons to achieve a full outer shell of electrons. We can use a dot and cross diagram to show how two atoms with an outer shell of 7 electrons, where it would need to gain one more to have a full outer shell, they share the electron and they both have a full outer shell. We can see examples like methane, ammonia, and water. For example, water, we have the oxygen, which has an outer shell of 6 electrons. However, it is joined up by two different hydrogen atoms, which both have one electron in its outer shell, but as it shares, they both share with the oxygen, they all have an outer shell of 8, which is a maximum amount. In this learning objective, we explored the intermolecular bonding structure model for simple molecular structures and explained the physical properties in these structures. So the first properties are low melting and boiling points. This is due to the fact that there is little energy needed to break the weak intermolecular forces. There are strong covalent bonds between the atoms, but the intermolecular forces between the molecules, which we can see below, are very weak. Therefore, they have low melting and boiling points. They cannot conduct electricity, and this is due to the fact that there are no free electrons and a overall electric charge cannot be traveled across.